Now, it is very easy and simple to graph a linear function. So let's look at this problem. Here we have to graph the equation y equals negative x plus 3, and then using our graph to find the y when x is 4. Now, what we can do to graph the linear function is by making a table, an xy table. So the first thing I would do is create an xy table. X is the values that we can choose. We can choose any numbers that we want to use for x. And how do we find y? We're going to plug it into the function, y equals to negative x plus 3. And then whatever the outcome is will be our y. So let's make a table for 5 values. And normally I would use some positive, some negatives, and the 0. So I would suggest use the number negative 2, negative 1, 0, 1, and 2. But again, you could use any values that you want depending on the problem. If your problem is very big, you might want to use in increments of 5s or 10. But normally it will be very wise for you to choose 2 negative, 1 0, and 2 positive values. So now let's plug it in. If I have to figure out what y equals to, I would do the original is negative. My x value here is negative 2 plus 3. So let's calculate. Negative 2 means positive 2 plus 3 would make 5. And then just continue to plug in the next value. For x, now we have negative 1. Negative 1 makes positive 1 plus 3 would be 4. And then continue. And if you choose to, you might want to write all of them first and then calculate if that's easier for you. Negative 0 means 0 plus 3 is 3. Negative 1 plus 3 is 2. Negative 2 plus 3 is 1. So here on this far end, I'm going to put all of the x and the y's together to create our order pair. So in the last column, you see that we have the order pair of negative 2, 5, negative 1, 4, 0, 3, 1, 2, 2, 1. So these are the 5 order pairs we're going to use to graph our function. So right now on this side, let's make an x and y axis. Since I have some negative, for the y's it's mostly positive, so I can make sure that I have more room for on the top for positive values for y. And don't forget, this is the y-axis. The horizontal one is the x-axis. So let's put in some tick marks. So we could do a quick sketch of this graph. We have negative 2 on the x, then 5. 1, 2, 3, 4, 5. And then we have negative 1, 4. 0, 3, 1, 2, 2, 1. And then try your best to make a straight line connecting the 5 points. Not very straight on this end. There you go. So this would be the sketch of this linear function. Now, why do we call it a linear function? Because it creates pretty much a straight line. If you see in the word linear, we have the word line. So we have a line, make sure it has to be non-vertical. So this is a linear function, and it has a constant value. It has a constant slope, a constant rate of change. Because every time we get to the next point, it goes down at the same increment, at the same rate. So if we see that a function had a constant rate, we can say that this is a linear function. And for particularly this particular example, my rate is going down, so I can make a prediction. Let's say if I want to know the value of y somewhere down here, I could just look at the graph. Where is that located for the y value for a particular x? In this problem, it says use the graph to find y when x is 4. So on the graph, I can see where 4 is. So here's 4 for the x. And then go down to the line where it intersects and then go across to see where it is for the y. So I can make an assumption that using this graph, my y would be about -1 when x is 4. And if you look at the pattern, if we continue, the next one will go up 1. The y's are going down, so I'll go down to 0. My x would go up, my y would go down 1. So we can say that our estimations, our assumptions is pretty accurate.